to start the recording, Linda? Or maybe
Already got it.
you already did? Okay, so you guys are being recorded, and wow, it looks like Linda has these notes up here and everything else. We're blessed to have Linda. She helps us out a lot. So Linda, let's go to the first slide here and see what it is. Okay, I am going to give you guys a little bit of a road update. I am being extremely well fed and getting a lot of hospitality and a lot of support, and it is good to reminisce about my my mother and others here, and the funeral is tomorrow, and so I should be on the road tomorrow sometime late in the day, and be home again, and so this is almost over. So thank you for your many of you sent me wishes of condolence, and thank you for that, and thank you for your patience. But I think we really didn't lose much ground at all with our studies, and we'll talk just a little bit more about that. So that's the road trip update. Tonight, what we're going to do is I did deploy a couple of videos for you to watch, and I want to emphasize that everybody should be watching those videos, whether you're in the VCM class or the other class, because I'm treating these classes as much as possible as one. And Linda and I are recording this VCM class so that the people who are in the net class can watch it, and we're also inviting people here. So that is all good. And tonight we're going to do examples and questions and answers. So that's what's happening tonight, and we'll have slides, and Linda will be helping with these and things like that. So that is all good. I'm trying to make my screen just a little bigger here, the way I'm looking at it, just so this shows up a little better. Linda, can we put a poll in the field about how are people doing?
You got
and
it.
That gives us how many people are here and so on and so forth. Okay, so people, please vote. Okay, maybe we can just call that to be it. I'm looking at this and I see 2 greats and 11 okays, and that's okay with me. And in fact, given all the love I've been shown both here and through your emails and stuff, I'm putting myself as somewhere between great and okay. So that's all good. Okay, I'm going to throw this open. If there are questions, you can either raise your hand and get recognized, or if you want to, you can send something in the chat box. And Linda, let's only spend a couple of minutes on this. I mean, we'll spend more than that answering questions, but if there's something else to be talked about, we will. But we'll wait maybe just a couple of minutes to see if there are any questions or issues that are sitting out there. And Lindsay, I'm going to recognize her hand is up. And Lindsay, I hope you don't feel embarrassed, but when you raise your hand, I'll try to call on you that way. Not just you, but anybody that does. So Lindsay, go, please.
Did you mean Sydney?
Sydney, I'm sorry.
It's okay.
I was up late last night talking, and that was not an excuse, I guess, but that's a fact. So anyway, go ahead, Sydney. I'm sorry.
Okay, so for like relative frequency charts, like when you make when you do the relative frequency, if the percentage is higher over the chart bar, what does that mean?
Well, that might mean first of all, that might mean that you have to adjust your axis. Now, and so what happens is when you get the data points, but if you have it going from 0 to 1 as a as a number, that means that your chart isn't big enough. And one thing you could do is you could click your chart and drag and drop and make it bigger, and that would increase the size. There are also special functions that you can go in and you can change, how long you want the axis to be and things like that. I guess what I would say is that would not earn you an F on the problem, but I kind of would, well, the observation or the feedback is, well, you can format the chart better than that. Now, I'm going to throw that to Linda, but that just means you didn't, well, it also could have meant that you made some kind of a arithmetic mistake, but I'm assuming that your arithmetic was good and that Excel did the arithmetic good. So I'm just going to say the lengths of your axes are not good enough, or not big enough. Linda, you have other things you want to add to that?
If it's going past 1, then there's probably some kind of Excel formula error to look at. So feel free to email me the file and I can take a look at it as well.
Okay, I'll email it to you, Linda.
Okay.
Yeah,
Okay.
and the number should not, in a relative frequency, it should not go above 1. I mean, so, something should be 0.469 or something.
Okay.
Okay, we're going to assume that that's either answered or, Linda will answer that in some way, shape, or form. Okay.
Someone wants to know when the PDF upload and the assessment tab will be opened for the low stakes assessment 4.
When is it due, Linda? Or, I mean, that's a question I would pose. Well, let me tell you what's happening here. And by the way, I was able to get internet access and get in this way, but it's not quite as simple as what I did before. Now I need to think about low stakes assessment, and I guess I'm going to ask: does anybody out there, and you can use the chat thing, does anybody know when this is due?
Someone said Monday.
Okay, well, here's what I'm going to say. I plan to be home tomorrow night after the services are complete, and I want to stay here a little bit with family, but I'm going to be leaving here, and so tomorrow night I'll be home, and I should be posting it. I have to remember to post it in both classes and things like that, but I guess I'm going to say I'll say Saturday morning is when, and I don't like to make any promises that I can't keep, but my current plan is, yeah, I'm going to be home and up in my bedroom by that time. So I'm going to just say let's target Saturday morning, and if I'm really ambitious tonight and don't have many students in my office hours, and I'm not telling you not to come, I want you to come if you want to. It's possible I could do that tonight, but also, I'm juggling several things here, and so might not happen. One thing I have to do is, it's been a long time, Linda, since I've worn a suit, and I kind of just threw the suit in the car, and so I'm going to go out and I'm going to see, do these pants really still fit me? Now, I think they do, but I'm going to be doing some of that stuff also. So I hope that answered the question.
Yeah.
And I really wish we weren't in a COVID environment where I had to have all these elaborate protocols for turning things in. It was just, you're in a room with me and Linda, and I say, yeah, pass these papers in, and that would be it. But we're not in that kind of environment, so we have to do what we can do. And Linda, you said that was a okay answer. I mean, that was clear.
Yeah, that answers the
All
question.
right, excellent. Anything else, Linda, or we'll move on?
I think that's it.
Okay, now Linda, and I think Linda probably has a fervent prayer that maybe Jim will send this early and I can do some pre-work on these things, but I rarely do. In fact, maybe I never do. So Linda might be entering some of this data in, but by the way, you guys can be entering it in this too. And this is the way you're going to be, confronted with a test problem or something. It'll probably look like some of these things. So Linda, let's go ahead to the next slide. Go back. Yeah, just let's stay on this one just for a moment. Now, the reason I included this slide is I did post lectures today, and the lectures I posted today dealt with all these formulas. And these formulas are going to be available to you on the high stakes assessments, but they're just going to be listed like this. And so, you have to know what is the formula and, how do I use it and stuff like this. So in the 2 videos that I posted today, which are new lectures, I cover chapter 5.1 and 5.2 in the Sullivan book. We have these formulas that are presented there. And I'm just showing you to say, hey, there is some meat in that. And when Linda and I do the problems, we're going to refer you to these. You might be saying, wow, I didn't look at those videos yet. That's okay. Play along, look at the videos, and you see these, and you will be, we will be fine. Okay, Linda, go ahead then, please. Okay, so we got this thing. Now, this thing is data, and Linda's probably entering in right now. I am trying to make my screen bigger, and I'm trying to figure out how to do that, and I'm just going to well, let's see, maybe I can do it this way. I'm trying something a little else here. I'm just going to leave it there. But anyway, enter all that stuff in, if you will, Linda, and everybody else. I'll just say this. Viagra is a drug that people can take. But anytime they're doing clinical testing on a drug, they really try to figure out what kind of side effects it might have. And this is an example of, and this was in some of the statistics videos you looked at earlier, but they also put a placebo in here. So here's what they do. They have 734 men, in this case, who were recruited, and actually they have 734 and 725. And they tried to get the same number, but they weren't able to get the same number of it, or for some reason they split it up this way. They were trying to split it up, the right way. And you might say, well, why didn't they do it equally? Well, they would have had to cut a person in half to do that, because that's an odd number, and it really is sometimes hard to get people to participate. So anyway, for some reason they did this. Now, chances are, in fact, I'm sure that's what happened here, this was an experiment. And so what they did is they said, okay, we're going to give you a pill, and then you're going to report some things that were happening with you. And so they don't tell you what you're getting. This is called a blind study. And so some people were getting a live drug called Viagra, and other people were getting some kind of a pill, and it looked the same as the other pill, but it didn't have any active Viagra ingredients. And usually people refer to this as a sugar pill, and so it really doesn't have those things. And then they have these people fill out questionnaires, or they interview the people or something, and they ask them these questions. And so these are symptoms that they get. And none of these things are nice. I mean, like diarrhea is no good. And so these are all adverse effects, meaning they're not good effects. And some of them are quite bad. And they're trying to figure out, well, so are there things we should warn people about this drug that we're testing? And by the way, if they find that almost everybody has these adverse effects, they say, well, we're not just going to warn them. We might not even let the drug be done. But anyway, this is a kind of experiment, and it's a medical experiment. That's why I thought it was a good one to talk about. So anyway, is the variable adverse effect qualitative or quantitative? And again, we talked about, well, quantitative is numbers, and qualitative is not numbers. And so, and Linda, I'm going to ask you, and Linda, I'm not testing you, but I'm going to ask you to respond to that. And by the way, the reason I'm asking Linda to do that is I think a case might be able to be made for either of those, but I'm just going to, and I'm going to tell you which one I favor, but I'll talk about the case. So Linda, which one of those would you answer? And you have to answer one. You can't do what I do. I said it's a little of both.
I would say it's qualitative.
In fact, you know what? I was looking at this in a wrong way. I'll tell you what I was thinking about. It definitely is qualitative. Okay. Now, and I'll talk about the other thing. So, okay, in fact, if I ask, do you have a headache? And actually, my head was aching a little bit earlier today because I didn't get a whole lot of sleep. But if someone was asking me, how you doing? I probably wouldn't tell them I had a headache. You know, I just would say, hey, I'm doing okay. So yes, headache is something that's relative, it's qualitative, but what somebody would probably write down in the coding sheet, if somebody in Viagra said, yes, I have a headache, they would put a 1 there. And if they didn't have a headache, they'd put a 0 there. And the same for the placebo. Now, so all I'm really saying is that's a little bit of a goofy question. And also, I'm a bigger fan of asking questions that are where the answers are numbers or something. So don't worry about that. But that's my comment on that. And I think Linda's answer was excellent, that they're qualitative. Okay, now let's go to the
Part B.
next thing. It says B. Well, which type of graph is appropriate to display the information in this table? Well, one thing that they could do if they wanted to is they could make you could make a box plot, for example, of this, and you could compare, you know, the number of people who had different, you know, the placebo and people that had the ill effects with Viagra. Now you got to be a little bit careful when you do this box plot, though, because like it may say, okay, so how do headaches compare? And so you could talk about that versus those two, or you could talk about the total number of adverse effects to do that. I don't know actually, and that's a wonderful thing with Excel. You could actually say, let's see what this looks like and do it. And if you say, oh, that didn't make any sense, you could come back. Anyway, so Linda, I'm giving the ball back to you, and you could say some things maybe beyond what I said or something.
So since we're comparing Viagra to the placebo, then I would say a bar graph would probably be the best.
Okay.
So kind of a frequency chart, like what we had made last time.
Okay, so she hit it, and there it is. And so as I look for that across there, certainly Viagra did have some effects. And one of the things that will happen is when they do a commercial for Viagra, they probably will have someone who talks very fast in a low voice who will tell you about, oh, it can cause headaches, flushing, you know, all those things. But then they'll show, you know, someone saying, but, you know, I felt like a teenager again or something like that. And so you're supposed to react to that in the ad rather than, you know, getting flushing and headaches and things like that. But anyway, I think Linda's, you know, thinking was good. We could change those into a relative frequency chart. We're not going to bother doing that today. And Linda, that was good. And that actually was a, well, that was a good answer. And you want to know what are we going to do when we're doing this? Okay, let's see what question C is. Question C was, what is the estimated probability that a randomly selected subject from the Viagra group reported flushing as an adverse effect? So now that can be answered pretty directly from the table, and I'm giving the ball to Linda again to talk about how she does it and so forth. And we'll return and we'll say, is this unusual? Go ahead, Linda, please.
So we're only looking at the Viagra group. So the number of people who experienced flushing in this case was 73. And the total number of people who took Viagra would be 366. And when we divide those, we get 0.19945. So that would be the approximate probability that they would get flushing as an adverse effect.
And I think we've talked about this before, but we're talking about it again. In our statistics course, we're going to declare something to be unusual if it happens more than 5% of the time, or you know, 1 out of 20, and that's way more than that. So it's not unusual, at least in our clinical trial, for people to flush if they're taking Viagra by our definition of unusual. Now, I'll tell you, some people would consider that perhaps worth the risk. Say, yeah, 20% had that, but I think I'm going to be part of the 80%, or it's worth a headache or something like that. So anyway, that's the answer to that one. Please ask questions if you have it. Now we're going on to the next problem. It says, what is the probability that a subject receiving the placebo? Oh, it's the same thing, and they'll do that. And Linda's maybe, well, okay, so she's doing it for the other one, for the placebo.
Okay, so I'm taking the number of people who experienced flushing on the placebo and dividing that by the total number of people who took the placebo. So we got 0.06863, which still would not be unusual.
By the definition. Now, I'll also tell you that there is a thing called in medical circles, and I'm not a doctor by any means, but in medical circles, what happens is there's a thing called the placebo effect. And you see some people, and this is a psychological effect, but if somebody says, oh, I'm taking a pill that will help me get better, whatever that means, and they actually will get better because of it, and they might, even experience some of the side effects. But Linda answered that correctly. Not unusual. Okay, so then we're to E. And if a subject reports flushing after receiving a treatment, what might you conclude? And I don't think you can conclude anything. And I guess we have to figure out what treatment means. Sometimes treatment means, oh, I gave them Viagra, and I don't think there's anything that would conclude there. And if someone said, oh, I flushed, you couldn't tell, well, were they a placebo person or were they a Viagra person? But you might think, well, there's a 20% chance if they were taking the Viagra, and there's a 6% chance they're taking the placebo. So there's a chance. In fact, there's 3 times as large of a chance because if you took that 0.06 times 3, you would get something close to 20. You're 3 times as likely to be one of the Viagra people than you are the other. And I don't know, Linda, how you want to write that, or maybe you have some additional comments on that. But that's, I guess I would say if I were right. Yeah, go ahead.
I mean, in this case, since they're both not unusual to experience, then there's really no solid conclusion that you can make. I would say since the people who were on the placebo had a significantly smaller chance of experiencing flushing, then it's probably more likely that they took Viagra. But we still don't really have enough information to make that kind of cut and dry conclusion.
Okay, excellent. And part F says, what type of experimental design is this? I would say this is a controlled experiment because you split people up into 2 groups. One group is a controlled group. That is the placebo group. You say, well, what would happen if we didn't give them this drug? And the other place, they would be giving them the Viagra. Now, I will tell you that in technical terminology, sometimes it is, and I'm really talking about medical terminology now, the placebo people aren't really getting a treatment. They're not the treatment group. They are the placebo group or the controlled group. And they're the one you're comparing it against. And I think Linda's answer there is concise and right on. Okay, so that is good. I'm going to poll in case there are questions about this, but otherwise we're going to move on. Okay, so Linda, you must have been really clear on that. I think you usually are. Oh, she's asking. Okay.
Okay.
Maybe, okay.
Any questions?
Okay, I'm seeing an abundance of.
Oh, we got one.
There is a question.
Never mind.
So Okay. Okay, excellent, I guess. Let's move on then. So I'm killing that poll, and Linda's going to go to the next slide, and we'll see what that example is. I'm really a whole lot about, I mean, there will be some essay questions, and we might talk about that, but I'm a whole bunch more likely to ask you things. Okay, now this is called Ask Marilyn. And Linda, I'm going to warn you that this example, and again, you might say, why is he warning Linda? Well, the only thing I'm warning here is we're going to do this via a simulation, okay?
Oh boy.
So anyway, here's this person as Marilyn Voss Savant, and to tell you the truth, I think that was probably a stage name. I bet her given name probably was not Savant, but anyway, so I'm reading this, I guess, and 4 identical sealed envelopes are on a table. And I got to figure out how to make my screen look different. But anyway, I think it says one contains $100. So you were to select one of the envelopes, and the game show host discards 2 of the remaining 3 and informs you that the one he threw out, did not contain the $100. In addition, the host offers you the opportunity to switch envelopes. What should you do? And by the way, you might say, oh my God, this is a formidable problem. And actually it is. And what we're going to do is we're going to address this by performing a simulation. And I lecture in those videos about simulation. And in a simulation, what you do is you conduct an experiment, but often it is just a computer experiment. And the reason you do a simulation is that it is either safer, that's why you do flight simulators, or it is quicker to do this. Like, suppose you really wanted to conduct this experiment, you would have to go out and get a whole bunch of people, and you'd have to bring them in, and you'd have to see what they did and record it, and it would be like really a mess. But we're going to do a computer simulation of this, okay? And by the way, when you do a computer simulation, you have to think about things pretty deeply. And so you might not come up with this until you do that deep thinking. But Linda and I have thought a little bit about this before. Okay, so here is the thing. You picked an envelope, and there were 5 envelopes. And so you picked, in fact, Linda, I'm wondering if I should shut up since you started typing.
Wait, there's 5? I thought there were only 3.
Well,
oh, there's 4.
Okay, but look what happens. Okay, yeah, and Linda, you changed something so I can see the whole thing, so that's good. All right, so here's the deal. Yes, there are 4, but you don't really care that there were 4, because here is what happens. You pick one envelope that is yours, and then the host throws away 2 envelopes that are irrelevant to the game, because
Okay, gotcha.
he's telling you that, and I'm just going to finish my thought, Linda, and I know you got it, but he's telling you that, hey, it wasn't in those. But then you say, I left one there. So you see, you as a smart cookie say, oh, well, it is either in the envelope that I have, or it's in the other one. And I don't know if I finished reading this. Maybe I didn't. So anyway, we got to the point where there are 2 envelopes in play. So then the game show host, I already said that, discards 2 of the remaining 3 and informs you that they don't contain the 100, the ones he threw away. So you don't care about those. In addition, the host says, hey, if you want to switch envelopes, you may. So the choice is you should keep the envelope, switch, or it doesn't matter. And by the way, don't worry, this isn't getting graded, but I'm going to ask Linda to toss a poll in the field and tell us what you think. And then Linda's going to work through this problem with a clever simulation. And we're really what happens. And Linda, I don't know, Linda can do multiprocessing probably, so I'm just going to say, and Linda will do the random in between kind of random number generator function for this. Oh, she didn't leave, it doesn't matter. Okay, all right, good. So we're getting some data.
Okay.
And by the way, someone said they didn't think it mattered, and that certainly is a valid choice. But now Linda's going to do this. And Linda, I don't know how many you want to do. I'm going to suggest that you do 100 just to make the arithmetic easy. So Linda's going to say, let's play 100 games.
Okay.
And Linda, I'm letting you talk now, so you tell students what you're doing, so on and so forth.
So
please.
I'm using the random between function to randomly pick my envelope. So in this case, there are 4 of them. So Professor Bradley, do you know if this includes those numbers or not?
I think it does include those numbers.
Okay, so then I'm going to do 1 through 4.
Well, yeah, but okay, yeah, 1 through 4, yes.
Okay. So let's do, I don't know, 100 trials.
Yeah,
That
but
should be
Linda,
good.
let's go back on that, okay?
Okay.
This is your chosen envelope. You see, even though there were 4 envelopes, and Linda, this goes back to our discussion before, and I did answer your question, but I think I answered in a misleading way. I was not trying to do that. There's only 2 things that matter, okay? Either you, so really this chosen number is, that's what, you know, it's, so you're either going to keep or switch, okay? So let's do it this way, okay? Let's go and say envelope containing. So in C, it's when by, here's what I'm trying to say. Is it in, all right, this is going to be a 0 or 1, really. Is it in, or we could call it 1 and 2. Let's call it 0 and 1. It's, is it in the one you picked, or is it in the other one? Now, what Linda's doing right now is, where's the cache? So Linda, column C is, where's the cache? Is it in?
Well, that's what I was doing in column B.
Oh, okay. Maybe I'll shut up and let you do it. But I guess what I'm saying is, when you pick that, you don't have to, what I'm trying to say is, you picked an envelope. I don't care which envelope it was. It's either the envelope that you picked or it's the other one that the host gave. And maybe
Yeah, I gotcha.
All right, I'm shutting up. Go ahead and talk. Go.
Okay. So I'm doing 100 trials, so I'm going to drag this down to 101. And then I believe I actually need to copy and repaste that. That way it doesn't change. And then I'm going to do the same function here for the actual winning number. So rand between, and this is 1 through 4. And then I'm doing the exact same thing, dragging this down to 101. And then I'm hitting Control C and Control V. That way it won't change. So now what I'm doing is I'm going to find the difference between these. That way, if the difference is 0, then I can count all the zeros at the end, and that'll tell me how often I won by keeping my same envelope. So all I'm doing is equals, clicking here, minus, there. Oh, that didn't do that correctly. Hold on. So copy, and then I want to paste as numbers. There we go.
And Linda, that was useful because some of the students might not have followed all that, so that was good.
So then I'm dragging this all the way down. And you can see I get different values. But really what I'm interested in is how many times I won. So if I do this, then I'm using a COUNTIF function. And I'm not familiar with the arguments, so I'm looking it up.
And by the way, that's another good thing Linda is demonstrating for you is, gee, if I don't know exactly how that works, how will I do that?
So the COUNTIFs function, okay. So my range is the number of cells that we're looking at, so that would be over here. And I want it to equal 0. And you can see there that it gave me 29 zeros.
Out of 100.
Yes. So the probability of win by staying is approximately 29 divided by 100.
Now, and then probability of winning by switching.
So that would be the complement. So if I do that, then I'm doing equals 1 minus, and I'm taking the probability of winning by staying. You can see there's a significantly higher chance of me winning if I switch the envelope.
Now, I think that the poll, a bunch of you thought otherwise. You thought, I'll just keep the 1. And later on, not tonight, because I want to talk about conditional probability before we do that, but later on, I will work this problem for you without doing a simulation. But I think you want to realize, oh, the cleverness in the simulation, I got an answer, and I really got a sense of what happened without really being able to or understanding the underlying analytical thing. And there's a whole section in your book about simulation, and I talked about it. There are other examples here, but I think this is a very good example. And Linda, I think that's great. Now I'm going to ask if there are any questions, and we can either just let that sit out there and somebody can ask questions and I can count, or Linda may want to poll. What are you going to do, Linda?
I'll do a poll. We're having fun with those.
All right. We're trying to make this class somewhat interactive, even though Linda and I are dominating the discussion.
Well, there's at least one question.
So, and if you feel up to it, go ahead and ask the question that you have. And you can, it's not tweeting, it's the chat box or whatever you ask the question in. Or if not, we can, you can ask it in GSG or Tom Topol or something, or me in my office hours. Okay, I'm not hearing any question, Linda, and 7 people aren't responding. Let's just pretend it's good. And I don't mean we're pretending it's good. If somebody did have a question, we want to answer it, but we're moving on. Okay, so let's see what is next on this program, Linda. I'm watching the clock for you guys. We're doing fine. Okay. Okay. Now that, oops. We didn't have any, or did we have other questions or no? That was it, right? That was the one we finished?
Yep.
Okay, Marilyn is finished. Okay. Now, the real reason, Linda, I showed this here is that there are going to be problems we're going to talk about that are involving a deck, a standard deck of playing cards. And there's some pictures as a little bit of visual aid. Now, in fact, Linda, let's do a poll. How many are like super familiar with this? Or how many of you say, I've never seen it? And you're not saying I've never seen this before. So Linda's poll is going to be, are you familiar? And we're not going to explain this, but if there's people who say, I don't know what this is, then we'll have Linda maybe explain what this is. So she's launching a poll to see if this is familiar to you, yes or no. Now, Linda, there is one person out there who says they're not familiar with this, and I believe everybody's question should be answered. So can you speak a little bit to this and just point at the figure or something and say, and it looks like maybe there are two people who are unfamiliar with this. And I sometimes ask questions about this. Now, I've got to tell you, maybe I'm growing as an instructor because one thing is I used to just assume people knew what this was and things like that, but now we've learned through the poll that there are people who don't. So Linda, can you speak to sort of the dynamics of this thing? And feel free to point if.
Yeah, someone was asking me why they couldn't see the Excel. I'm not sure why you aren't able to see the Excel spreadsheet, but I mean, is anyone else having trouble seeing the Excel spreadsheet when I was sharing my screen earlier?
All right, several people are saying no, which
Okay.
means it's good for them. So there may be.
Yeah, I'm not sure how to help with that then.
It seems like it's an isolated problem, maybe.
Okay.
And by the way, what they should be able to do is if they watch the video, again, this is being recorded still. So if they watch the video, even if they're not seeing it on the screen, it ought to show up in the video. Yes, Linda?
Yeah.
And by the way,
so,
one of our technical students out there said how to fix that. I think they were telling the student how to fix it or something.
Okay. So as far
All
as playing cards go, then there are 4 suits. In this case, we have spades. I'll point to these. So spades, hearts, clubs, and diamonds. So you can see that the numbered cards are labeled from 1 through 10. And then we have face cards, which are jacks, queens, and kings. So each suit has their own version of that.
Okay, excellent. And then, oh, I just realized how I should be doing this. I should be pulling the screen down now that there, or not the screen, but how come that's not working? Oh, well, there it is. Good. Okay, now there's some questions down there, A and B. I guess there's A and B, Linda.
Okay.
Let's deal with these, and I'm just going to let you talk. And Linda, if you're getting worn out, but my goodness, you were so pleasant and quick on this stuff, I'm just going to let you roll with this. If you're not, so go ahead and talk to it.
For part A, then they're asking the probability of drawing a king. So actually, if we look on here, then there are 4 kings that I'm boxing up. So that is the number of events that we're looking at. And out of the 52 options, so the probability would end up just being 1 out of 13 when you reduce that.
Okay, now question B, however, is talking about computing the probability of event E. Now, this requires you to understand some of the formulas from the lecture that I videotaped. Now, if you didn't watch that yet, that's fine, because you can watch that again, and then you come back and watch this again, so that's all good. But we're using something from that, and that was one of the equations that Linda flashed at the beginning of this presentation. So this says, compute the probability of event E drawing a king, or, and the or is an important word, it's not and, it's or, F, drawing a queen, or drawing a jack, okay? And so, Linda, can you speak to this one, please?
So any of these outcomes would count as a success. So we're looking at the 4 out of 52 chance that you draw a king, plus the 4 out of 52 that you draw a queen, and the 4 out of 52 that you draw a jack. So in this case, you actually have 12 outcomes that would count as a success out of 52, which when you reduce
Linda,
that would just give you 3 out of 13.
Now, Linda, I am thinking of a word that begins with a D, and
Disjoint.
DISJOINT. Yeah. Why don't you speak to it? Because actually you implicitly or maybe intuitively or whatever did that, but it's important that the students realize that that was part of your thought process.
So if you draw a king, then you obviously did not draw a queen. And if you draw a king or a queen, then you obviously did not draw a jack. So because you can't have both of those happening at the same time, then we didn't need to use one of these formulas from before.
Actually,
so
well,
using that.
Yes, good, excellent.
Compared to this, where we have the probability of E and F, but because there's no way for that to happen, then we can use the addition rule for disjoint events.
Okay, wonderful. And so I'm going to poll. Linda, I don't care if we poll or we'll do what Linda wants us to do, but I'm saying, are there any questions on this or else we're moving on? Are you polling, Linda, or just what are we doing?
No, we'll just let people answer.
Okay, so no one is. I'm not hearing anything, so I'm saying let's move on. And again, I'm not trying to be rude with that, but I just want to maximize your learning. So let's go back and see what else we find that we can talk about. Excellent. Now, here is a bunch of problems. I'm fooling around with this. I'm trying to learn, and I think I want to. No, that's the wrong way. I'm going this way. Anyway, what Linda is going to do is she's going to use the fact that the probability of the indicated event, the probability of E is 0.25, the probability of F is 0.45. And is there anything else up there, Linda, that is off my screen and I haven't figured out how to fix that?
No.
Okay, that's good. Now, Linda, let's don't worry about, let's see, so that's the probability of E and the probability of F. So let's just pick, we're not going to do all of these, but let's pick a couple of them, okay? Let's do, well, what the hell? Let's do number 13 to start with, okay?
Okay. So I'm going back to that formula that we had just looked at on the other screen. And that means the probability of E or F equals the probability of E plus the probability of F minus the probability of E and F.
She's a graduate student.
So then I'm
okay,
basically
that's just
plugging in numbers. So we're finding this. So the probability of E or F. And then the probability of E was 0.25. The probability of F was 0.45. And they tell us that the probability of E and F is 0.15. So if I toss this into a calculator,
or do it on Excel.
Yeah, I could do that too. But you get 0.55.
And actually, I got to tell you, I would have done that in my head. And I'm not bragging. I'm just saying that you guys can do that in your head without even firing up a program. Okay, Linda, let's do 2 more of these. And I'm going to suggest maybe, it sort of doesn't matter, but let's do 17. And then let's do one where we have to do a little bit of algebra, number 19. 17 and 19, Linda, please.
Okay. So I'll erase this. For 17, then we're finding the probability of E complement. So remember, to find the probability of a complement, then you do 1 minus the probability of E. So in this case, that is 0.25. So 1 minus 0.25 gives you 0.75.
And again, that is in the videos, and you might say, oh, I haven't watched them yet. It's all okay. You can go back and watch those videos and then rewatch this, but that's how all of that hangs together. And then last but not least, Linda, let's give number, whatever it is, 19 a go.
Okay, so I'm using that same formula that I referenced in the first problem. I'm not going to write it out again. I'm just going to start filling in the blanks. So the probability of E or F is 0.85, and that equals the probability of E plus the probability of F. So they tell us the probability of E is 0.6. We don't know what the probability of F is. And then the probability of E and F is 0.05. So minus 0.05. So I'm going to simplify this by combining like terms on the right-hand side. So 0.85 equals the probability of F plus 0.55. I can subtract that 0.55 from both sides. So the probability of F equals 0.3.
I am going to make a statement. I'm going to provide toothbrush or something. Or maybe something. Okay, any questions on what we just did there? Because we were, advancing the cause and using some different formulas a little bit. So I'm going to count to 5 mentally, and if we don't hear any questions, we're just going to say, oh, that is all good.
And if you're typing a question, you can raise your hand and we'll wait for you to type.
But I have counted to 5 now, and so we'll move on. And okay. Again, I've got office hours, and we've got GSGs, and whatever Tom Topol calls his thing, D, dedicated math, DMA, I guess. Okay, so let's declare victory on this and move on to the next slide. Now, life is a word problem, and the reason I'm saying that is often these. Oh wait, there was a question there, Linda.
It was if you have office hours tonight.
Yeah, I guess. Well, let me just say it this way. I am planning on having office hours at 7:30 to 8:30. I'm asking my brother now because he knows, is Walmart open? How late is the Walmart open?
Okay, that's a watch.
All right, he's checking on that. I have to go buy some deodorant. I don't want to offend people tomorrow. So anyway, I have to buy toothpaste or something. But I think that'll all be good. So the answer to that is, yeah, I plan on being here now. And my my sister-in-law helped with hack into the router, and so this thing has been working. But I'm also going to be jumping off this and going into Zoom. So crap could happen, but probably not. And so I'm going to say, yeah, I'll plan on being there at 7:30. Whoever asked that question. But yes, that's my plan. Okay, so here we go, Linda. This is a life as a word problem, and there's a weapon of choice, and I've got to figure out how to do this a little bit better so I can see. Oh, that's it. So you see there's some statistics here. So it talks about probability of murders happening by handgun, rifle, shotgun, so on and so forth. But then there's a bunch of questions, and Linda, unfortunately, you've got to kind of create that for us to live with that. But we're going to go, and some of this is review and some of it's not, but we'll go through and we'll answer these questions that Linda has there. The first thing we're going to do is verify this is a probability model. And we remember from our previous studies that all those entries have to be bigger than 1, all the numerical entries, and they have to add to 1. And those are the requirements. So that's what we're going to test. And so Linda's going to have a spreadsheet, and we'll look at that. And I can tell you by observation that all those things are bigger than between 0 and 1. And so that's good enough. And Linda, I'm giving the ball back to you to talk about, well, how are you going to check to see if they add up to 1?
So all I'm doing is using the sum function in Excel and highlighting my probabilities, close my parentheses, press enter. So because they add up to 1, then it is a valid probability model.
Now, okay, so, and then, Linda, the problem B is, what is the probability that a randomly selected murder resulted from a rifle or a shotgun? So you see, this is saying or, and I guess what really happens is that the murder is either one of these things killed the person. Either it was the shotgun blast or it was the rifle blast. So these really are disjoint events. The murder weapon, the thing that really killed him. And some of you might be saying, well, suppose that 2 people shot the guy with those things. One of them killed him. Okay, and those are the statistics. So Linda, can you
if you
speak to
use
B?
both, then I think that would be other. But since these are disjoint, then all I'm doing is adding up the probability of the rifle and the probability of the shotgun. So hold on. That's the probability of my rifle plus, why is this happening? Plus probability of shotgun. There we go.
Okay, so that's the answer to the question. And by the way, it's probably not asking that, but well, maybe it does. I'm going to ask you, is that unusual? And the answer is yes, because that is less than a 0.05, which is sort of our threshold in this course that we use. So that's unusual. And yeah, you see, because I think probably these are statistics from the city and things like that. And I think people don't tend to use rifles in, things in the city, and they also don't tend to use shotguns. You tend to use a shotgun if you're hunting. Actually, rifles and shotguns are more hunting things. You might say, well, what about snipers? But that, this is an unusual event. Okay, so that is good. And now part C says, it's not good people dying, but you know what I meant. What is the probability that a randomly selected murder resulted from a handgun, rifle, or shotgun?
Okay.
So and by
these
the way,
are
those
still
are
all disjoint.
Right.
So I am taking the sum of the handgun, rifle, or shotgun. And because those are actually all in a row, then I'm just going to use the sum equation. And that works just as well.
Now I am going to, before I read the next part of this and we move on to that, I am going to tell you that, and of course I haven't written the midterm yet, but in the past, one of the things I sometimes do is I create a folder in your syllabus tab, and whenever I send out your test, I say, oh yeah, use the Excel spreadsheet that is in your syllabus tab. So you actually can do this fancy clicking that Linda is doing. You can add these things up, in a very quick fashion there. Okay, we're moving to problem D, which says, what is the probability that a randomly selected murder resulted from a weapon other than a firearm? And you notice that in the previous thing, we were really talking about handgun, rifle, or shotgun, which were the only things that were firearms, okay? And so I'm giving the ball back to Linda. Go ahead.
Okay, so I'm going to use the answer that we got from part C, since they were talking about the probability of a firearm being used, because we are finding the complement the probability that a firearm was not used. So I'm doing 1 minus, and I'm clicking on the answer that we just got for problem C, and I hit enter.
Okay, and then the last one says, are murders with a shotgun unusual? And you just, from the table, you say, oh, it's 0.025. That is less than 0.05. That means yes, that is an unusual thing, at least from wherever this data went from. I remark, even though it's, none of this stuff is interesting, it's kind of sad, but I also see that murder from fists is not unusual, and that means sometimes people are just beaten to death, and wow, okay. I don't like this problem just because there's so much violence in it, but the ideas in the problem are very strong and very powerful, and we could ask these questions about something that was yet less. Okay, so we're moving on. Are the questions? If you have questions, you really should be asking them, and just either hold up your hand or do the chat box or whatever. But I'm not hearing anything, so I'm moving on. Okay, so Linda, let's go to whatever it is thing on the hit list there.
Okay.
All right.
That's the next one.
Okay, now I'm going to do a little bit. Linda, I'm going to ask you, scan this and tell me, and just really quickly, and I'm not grading you on this or anything like that, of course. Should we do this one or should we skip this one? We have about 10 minutes left, 12 minutes.
I think based on the first problem that we did, then we should be okay skipping this.
Okay, now this might ask you to say, what's the probability of there being more than one room or something like that, and that requires you to add up a bunch of stuff, but I'm taking Linda's thing. It's good. Now, I think all of you students can go and try this on your own, and you should, because I picked this problem out, and I said, oh, this is worth talking about, but given Linda's wonderful explanation of the last one, maybe we don't need to, and I'm good going to the very next one, Linda.
Okay.
Cards. Okay, now this requires you to understand that thing that Linda explained about this. So one card is randomly selected from the deck, and Linda, let's do number B here.
Okay. So the probability of randomly selecting a heart or a club or a diamond.
Hey, Linda, I'm very sorry. C. And
Okay.
I'll read it. And by the way, I'm just trying to maximize the use of the time. And I mean, that first one you already even talked about that kind of in a different context. But I think C says, and it's going off my screen a little bit, but compute the probability of randomly selecting an ace or a heart. Is that the whole problem?
Yeah.
All right, so why don't you do C, and then we'll look at D and see if that's worthwhile. So that, and say, oh, Jim, you wouldn't ask this kind of problem. Yes, I would. So go ahead, Linda.
So the probability of selecting an ace or a heart, well, an ace and a heart is not necessarily disjoint because there is an ace of hearts. But we're going to need to use that extended OR formula. So I'm doing the probability of an ace plus the probability of a heart. We good?
Never mind.
Okay. Minus
That would
the
be a great
probability
password.
that it is an ace and a heart. So there are 4 aces in my standard deck of 52 cards. So this would be 4 out of 52. Plus the 13 hearts, because there's 13 cards in each suit. So that is 13 out of 52. Minus the one card that is both an ace and a heart. So that is minus 1 out of 52. So if I add these up, 4 plus 13 gives me 17, minus 1 gives me 16.
Okay, someone asked Linda, and I'll just paraphrase that. Why'd you use that formula instead of the other formula?
So I use that formula because, first of all, they're asking for an OR probability. So that tells me which formula I'm going to need to use based on here. So I'm looking at either this or this. Then the question is, are these events disjoint? Well, if I skip back to my cards, then because of this, the events are not disjoint. So that's why I had to use the bottom formula.
Okay, and I think that was well answered. And so, Linda, do we have another slide?
Okay.
Oh, wait,
Sydney, you have a
there's a
question?
question, Sydney.
What makes the problem joint or disjoint?
Can both of these things happen at the same time?
Oh, okay.
So for example, in part B here, then they're asking a heart or a club or a diamond. All of those are different suits, so I can't pick a club that's also a diamond.
Okay. All right.
And I want to commend not just Sydney, but all you people who are asking questions. That's what the name of the game is, and so you should definitely be doing that. So way to go, all of you guys who are asking questions. Good for you. And way to go, all of you guys who understand all this, because that's good too. Okay, so way to go, everybody. Let's go to the next thing. Is that the next slide?
Yeah.
Wow. Okay. Well, we've really, Linda was just ultra efficient tonight. I'm going to talk to you now just a little bit about, and I really probably should have thrown some more slides in here, but we'll talk a little bit about, you know, where we're going. Okay. And let's just have a little bit of I'm going to say a little bit of a dialogue. Now, there are two kinds of, there are many kinds of events. We talked about, events could be mutually exclusive. We talked about events could be disjoint. We're now going to talk about another characterization of events, and this is, are they independent or dependent? Okay, and so I'm going to give you an example of a independent event and a dependent event. And I need to be, and Linda, I'm just going to have a dialogue with you on this, okay? And I would have a dialogue with someone in the class on this, but okay. Linda, let's pretend that you do not interact with me at all on this coming Saturday. Okay?
Okay.
Now, Linda will either have a good day or a bad day on Saturday, or maybe it's just an okay day. But let's just say her day is either going to be good or bad. Okay? So that is event L, which stands for Linda. And then we have an event J that stands for Jim ate a good breakfast on that Saturday. Okay. Now, the question I'm going to ask Linda is, if your Saturday is good or not, and you're not interacting with me at all on Saturday, you don't see me, you don't hear from me, or anything like that, does the quality of your day, the probability of you having a good day on Saturday, depended all on whether I ate a good breakfast or not?
Not at all. I could care less whether or not you eat breakfast.
Now you might say, you mean Linda does not care about Jim? Well, yeah, but that wasn't the question. What I said is, does that influence whether she has a good day or not? And she is correct. So you see, one thing has nothing to do with the other, and that is called, those two events are called independent. They have nothing to do with one another. Now, this is a question where you maybe have to know a little bit about me, but maybe you know enough about me to answer this. Does whether I eat a breakfast, that is, and we'll call that event capital J, which is Jim eats a good breakfast, and then lowercase j will stand for Jim has a good day. Now, does it have something to do with the quality of the day I have, whether I eat a good breakfast or not? In fact, let's have a poll. Let's vote on that. What do you think? So I'm creating a poll. And we will vote. And there's a bunch of people aren't voting, so please feel free to weigh in. Now, some of you might not know me, so I'm going to say some more things to help your vote here. Jim often says, and it is really the way I feel, that breakfast is the most important meal of the day. And the answer is, oh, I mean, okay, so a lot of you are getting the right answer. And what happens is, I don't consider, and I guess we were talking about Saturday, I don't consider Saturday off to a good start unless I do get a good breakfast. And my day goes a lot better after that. It makes me happy. It gives me some energy, and maybe I even have some social interaction with my daughter or somebody like that. And so, yes, you know, that is. So the answer to that was yes, those two things, one depends on another. Right next to me, there's a jacket, and I could say whether I wear this jacket or not depends on if it's hot or cold, and we can talk about things being independent and dependent. Okay, and we're going to have a mathematical characterization of that, and there's going to be a video on that, and who knows, in addition to maybe posting the things for you to turn in your things on Blackboard, I may even make another video tomorrow night. We'll see how I feel after the events of tomorrow and my drive. Okay. Linda, it is 7:15, so time is precious. Each day must count. Do the math, it'll make you strong. And Linda, again, you were brilliant. So we're logging off here. I plan to have office hours in about 15 minutes for, you know, about an hour. Those will be on Zoom.